Hello, welcome back to AG Engineering. I've got another Triumph timing cover on the bench at the moment, and this one, as I probably introduced in a previous video, is for an oil seal conversion on the crank oil feed. On the one where I'm trying to get the drive screws out, that's already got the later one has already got the seal in as standard, so they did away with the bush and replaced it with an oil seal to feed the crank. So I've got a selection of seals here. We've got, previously I've done with undersized cranks. I've used a 22 by 15 by 4 seal in there, and that's worked okay. This one has got standard size crank, which is not 5/8, so we've got a 62 thou by 93 thou OD seal there, and that would probably not leave me much of a wall thickness there on the edge. It's just under an inch, and we're getting close to that side by the time we put a groove into it. We're right over there. On some of these, this boss seems to be a little bit more over this way, or it's been machined a little bit better, a little bit more centralised. So that one's not suitable. So I've got that one, which is 16 by 22 by 4, which is a little bit over 5/8, but I've tried this on the crank and the seal fit is fine, so we're going to have to go with that one, I think, to give us enough meat to machine into. So the other problem comes with trying to get a circlip in there, because by the time you get the ears of the circlip in, they tend to be sticking down into the crank area. So I've got one wire piston circlip there, gudgeon pin circlip, wrist pin circlip, that looks to be like it'll be about the right sort of size. So what I'm going to do on this one is do a wire circlip groove to retain the circlip. Next problem, this one's got a timing speed. This one's got a rev counter drive on it, so it's a lot deeper than the normal cover. So what I've got here, that I've used previously, are little homemade sort of machinist jacks. It's just lump of steel, faced off, a little bit of a taper on there, although you probably get away without that, tapped quarter wit with a quarter wit cap head, and they fit just nicely in them cap head screw recesses, counter bores there. So we set this up on the milling table like that, with 4 of those in suitable place, and we'll level it all up and then get concentric to that. So over to the mill. Once again, we're making use of the Wixie digital angle gauge there. It's sitting on a scale or ruler blade there. Zero it to the bed as previously, and then we're placing that on top of there like that, and then we can adjust this by the cap heads inside there. Move that so it the light comes back on again, and we can take it up and down like that. I'll go down with that one. Right, I've decided to go for 3 clamps. It was easier to try and level this. And say we're not on a super flat surface here on the it's not a parallel or anything, so we're within 0.1 that way. And 0.1 that way. And what we've done for clamping is we've put the clamps directly over where the jacks are, so we're not putting any pressure or twist onto the cover. Is the I'll just nip these nuts up underneath slightly. They're not going to go anywhere. They're fine. Next stage, you get the boring bar in, and we'll get concentric with the bush there. For this job, I've got a homemade, specially ground little grooving tool for doing the Circlip groove itself when we get to that stage. Just very thin, just the width of a Circlip or slightly under. And for the boring part, we're using indexable boring bar with our Corloy AK inserts in there. And there's the information on the inserts we're using. Finally give a good result. Again, like previously, I've swept this in and we're just sort of rubbing all the way round within a fraction there. We're getting a score line all the way. So I'll put a little bit of cut on, and we'll take a first pass. Now, depth wise, we need 4mm plus the thickness of the Circlip plus a little bit of material above us. So let me just have a measure. So we'll go down around about 7mm, 7.5mm will give us a little bit of wall thickness of the Circlip, which is just over 1.5 plus the seal. So we'll come back up and we'll put a little bit of cut on. And I know we've got to take the bush out to the casing before we start to consider how far we're going out into the aluminium. It isn't a great deal, there's only a little tiny step there. So once I start putting a cut on, I'll zero the depth readout, and then we can measure a depth of cut from there. At that point there, I'll just knock that off. I'm just going to set the depth stop up on the mill here. And a quick check of our cut. it's already a worn bush, but we've just took half a thou off or less there, just a scratch. There's a little wear patch, if that can be seen in the camera, over that side. I'm not replacing the bush. It won't sort of do anything once it's got a seal in anyway, and it certainly doesn't support the crankshaft. On most of these, the crank wobbles that much that that the bush just gets worn away fairly quickly. And by wobbling that much, I mean within a thousandth. So it soon sort of cuts itself its own path. So I'll put another just over 5 thou cut on there. I'm just going to nip those gib strip screws up a little bit, and we'll tack another pass. And that's how we'll continue until we're out into the aluminium. So I'll bring you back then. There we are. Took the brass out completely now. And we're nice and pretty nice and concentric there. There's just a little tiny shadow there, it's not even feelable, and it's lightly polished over the other side here. So, quick measure. Right, our seal is 22mm nominal, so that's for a 22mm bore, so that should measure just over 22mm to give our fit, which it does. 22 point, a bit tight there, 22.1412, something like that. So we bought a 22mm on here, and the fit is built into the seal, the same as the seal on the shaft. It's for a 5/8, well 16mm shaft, and that doesn't mean it's a 16mm bore there. That'll measure considerably less across the lips of the seal. There it's about 14.02, 14mm ish, so around 9/16 ish. So sometimes you see people who've measured the seals for these, and they measure the bore, they say it's a 9/16 bore seal. Well, that's not for a 9/16 shaft in that case, it's for a 5/8 shaft, because you ought to allow for the fit of the seal itself. Same as a circlip. is sized by the nominal bore that it fits, not by trying to measure the actual circlip itself. You'll never be able to do it accurately enough. So if I can just get in there, not quite square, there we are. 19.0 something, little bit. That's 3/4 near as damn it for the original original bush size there. So it would have been a 3/4 OD, 5/8 ID by whatever thickness bush in there. 19mm. So we've got 3mm to come off. So 40 thou about a millimetre, so we'll take 4 passes of 10th thou. That will take us to 20mm. And again, as before, I'll continue like this, putting a little bit of cut on and taking a pass. Okay, several passes later, there we are. We're just starting to go in. We're at 22mm dead on that, and we're just starting to press in. That'll be just a nice fit there. I'll just chamfer that edge by hand when it's out. So we'll look at now putting the circlip groove in. Now that little bit of remaining bush in there really can be popped out. There's enough of a ledge just there to register the seal onto. It's just about the same probably thickness as the seal body. So there we go. So that's why you can see how close we are there to that edge. By the time we've got a circlip groove in there, we're almost going to be seeing daylight. So you have to pick your seal sizes very carefully. As I say, this one with a 22mm outside diameter, 7/8, whatever you want to call it, will be just right, and it'll work for all the versions, whether that's centralised or not. Hello again. This is about a week later actually, although it looks the same. We've had a little bit of inclement weather around here. I've not been once again not been keen to come in the workshop. I've just had to have the heaters on for a while to get everything up to temperature. The inverter wouldn't go because it was too cold, and the digital readouts wouldn't go either because it was too cold. So I've got us a little bit of temperature up, and I've just turned the heater off because of the noise. I've had to move this clamp away a little tiny bit because I was going to catch on the edge of there. I've put the circlip groove cutting tool in there, and what we'll do here now is just under manual control, I'll just wind that out a little bit, so we're just touching the edge. That could be seen there, yes. And we know obviously where the base of that is. We're going to touch the base of the cutting tool onto our recess there, which is just there, and I'm going to set a 0 point on the quill digital readout, And then if we come up 4.5 millimeters, that gives us a 0.5 mil clearance for fitting this seal. So let's just show you what we've done. That's set at 4.5 mil. So that's our clearance we've got for a seal. As I say, just a little bit of extra clearance on the back of the seal to make sure the circlip goes in okay. And if we can see round there, we've got probably about 2-3 millimeters of extra material above the where the circlip groove will be as well. So if I need to widen it, I can come up slightly or even down slightly by 0.5 mil. What I'm going to do now, I've locked the quill at that point, and I'm also going to set the depth stop up here to make sure we don't go below where we need to be. So there's the depth stop set, just in case we have to move. Right, let's turn the speed down, power the thing up and put some cut on, see what happens. So we're not touching at the moment. Again, I'll stop it and I'll put a little bit of cut on. We can't go too mad because we're kind of digging in to where the groove's got to be, and all we'll do is that and let it just burrow its way in. Let's get the camera down a bit closer. I'll pour a little bit of light on as well. There we go. So that's just currently very slowly cutting a little groove, so there's not much depth to it yet. So I'll just stop it at that point, and I'll just put a little bit, like a thou or so, of cut on, so it's digging into the material, and we'll start her up again. And stop it again, just bring it round, jog it round a bit, there we go. Our wire circlip in thousandths is measuring 65 thou, so we want around about 30 thou of cut on there. So we've just put about maybe 2 thou on, so 30 thou seems quite a lot, so we'll put a little bit more on, a couple of thou. I'll probably end up just judging this by eye, so it looks about right as well. And we were at the 30 mark there. And this is the beauty of inverter control when it's not too cold. So we've taken, that's about 20 thou gone there. Well, it would be quicker with the automatic boring head, but this is nice and controlled, and you're not going to overshoot or anything like that with this, hopefully. Okay, there we have a groove cut. Whether that can be seen, I don't know. The next question is whether that groove is actually wide enough for our wire circlip, because just measuring these things here, I seem to remember I did that one for a standard circlip, which is measuring 45 thousandths, and we've got 65 thousandths, so we might be at 20 thou too thin there. So what I might do now is just come up a little tiny bit. Okay, that should have given us enough additional, just trying to get that in the right place for the Allen key, additional depth of cut there, width of cut for our groove. So now we can back that off. And now I need to just set up for a little milling cutter, and I'm just going to put a little nib in there just to make sure we can get this circlip out again when we have to. So with a little cutter in there, I've checked the depth of cut and make sure the stop's correct. All I'll do is take that sort of halfway over the circlip hole there, approximately, and we'll just put a bit of speed on. And all we'll do is plunge cut a little groove like that, just like a circlip groove in a piston, to enable us to get the wire circlip out. I'll dismantle this lot now, and we'll take a look on the bench. What I am going to do is just tap the remains of that little bush out of the way, so we don't want it coming loose and blocking any galleries off. And say the original version, which is on that cover there, it just has the oil seal in the retained by the circlip there, and no bush or anything behind it. So what we've done is emulated that. So that now should take one of our little seals. It's just a little bit of cleaner on there. We can see the little wire circlip removal indentation there. That should take one of our little seals quite nicely. Yeah, it's just starting to press in. I'm not going to push it in because this wants a good clean up before that's fitted. And again, the same for the wire circlip. At worst, we might have to find a little bit smaller one, and again, I'm not going to push that in. That's up to the owner here, because as I say, it wants a good clean up, and that plug coming out and everything, making sure we've got no debris in there. So there we are. That's another one done. I'm going to put that badge on there on the outside. Actually, remembered that. And which badge was that one? Tiger. Alright, I've got a couple of these going on all at the same time. Yeah. Right, that one, I'll put that on. So that's just 3 little drive pins. So that's it, that's that one done. And hopefully that's been of use to somebody. So it can have an ordinary Circlip in it, it can have a, that's a bit big, it can have a wire Circlip, but a wire Circlip's going to be better because of getting having a little thin seal there. So another job done, and I shall see you, let's put this up again as I end up doing, I shall see you on the next episode. Battery's just about to go flat, so I've just about made it this time. So thanks to all those new subscribers, there's been quite a few. A lot of comments and discussion on the Norton cylinder head exhaust port thread repairs, which was brilliant. I really enjoyed that. And keep watching, keep subscribing, and thanks for everything, and I'll see you again next time. Bye for now.